So when we tried to graph the sine of x, we used a table of values, okay? And we're going to do the exact same thing for y equals the cosine of x. So we'll take our table of values here. We're going to have our x and our y, and we're going to do our 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And we're going to substitute each of these x degree points into our equation here to try and work out what our y coordinates are. So when x is 0 degrees, the cosine of 0 is just 1. The cosine of 90 degrees is 0. The cosine of 180 degrees is minus 1. The cosine of 270 degrees, we're back at 0. And the cosine of 360 degrees is also equal to 1. Okay, remember 360 degrees and 0 degrees, they're actually the same. Remember, we've just done a lap around that unit circle. So of course we see the same y coordinates being outputted back to us. And we know that this thing is just going to continue to cycle around as we continue to do laps of the unit circle. So let's have a look graphically at what this might look like. So I'll zoom out a bit and we'll come down here and do a graph. And we'll come 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now remember, if I was to plot the sine of x, and maybe I'll do that in just a blue pen. Remember, the sine of x looks something more like this. Okay, that there is y equals the sine of x. And this thing would just continue to cycle through as we go around the unit circle. But we know what that looks like. We've done a video on that already. What we're going to do now in the red pen is plot our table of values here and work out what y equals cosine of x looks like. So when I'm at 0, I start at 1. So I'm up here. Remember, we're running on our y-axis from 1 down to minus 1. I start at 1 up here, then I get to 90 degrees, I'm at 0, then I come to negative 1, I'm back to 0 again, and then I'm back up to positive 1. So what does this look like? Well, I could try a linear line and just connect my dots with straight lines, like connect the dots, but we know that that doesn't happen, okay, and we saw that with the sine function. We see that it's actually curved. In fact, if you were to kind of graph this thing, you'll see that it kind of curves more something like this. Okay, so our actual portion from 0 to 360 degrees that we look at for a cosine function more looks something sort of like that. Whereas for a sine function, it's the more typical going up and down, that more sort of typical wave look. Now, if you were to graph this across, 720 degrees or 1080 degrees or something a bit longer, you would see that these guys are actually almost the exact same. In fact, if I was to pick this function up and move it along a little bit, so if I pick this red function up and I moved it to about here, so this point here came to here, and this point here would go to there, you would see that they actually are the exact same. They lie on top of each other. So they're actually, sine of x and the cosine of x are actually the same sort of graph. They're just horizontally translated a little bit. Okay, so there's a 90-degree horizontal translation between the two. And that's all that the difference between the cosine of x and the sine of x is that they just look slightly different because they're about 90 degrees out of phase, okay? And that's the sort of language that we look for, about 90 degrees out of phase. So we can use everything we know about sine functions now to start trying to graph cosine functions. So if we come down here and we do an example, perhaps, so we'll do one example, maybe it's y equals, maybe it's 3 times the cosine of 2x plus 2, perhaps. Let's see what's going to happen here. Well, this is going to be a vertical dilation of a scale factor 3. This is going to be a horizontal compression of a scale factor 2. So we're going to compress this thing like a slinky. And this guy here is going to be a vertical translation. And that one's not a scale factor. That's just 2 units upwards. Okay, so we're going up 2 units here. So nothing changes with our cosine function and our sine function. In fact, the equation's the same. It's a times the cosine of bx minus c plus d. The only thing that's different is the actual image that we're starting to translate is 90 degrees out of phase. So let's have a go at graphing it. I know what the cosine of x now looks like because I just proved it in the first sort of section of this video. The cosine of x does more something like this, okay, where I run from, there's my 360 degrees there, this here is 180 degrees, here I'm at 90 degrees, and here I'm at 270 degrees. So that's just the general shape of a cosine graph. But what I need to do is I need to do these three things here now. So we'll do them one at a time. So first of all, let's do the vertical dilation. So here I'm running from 1 to -1, but now I'm going to need to run from 3 to -3 because I've got this 3 out the front. So let's sort of graph that now. So I'm going to have the exact same sort of image, except it's now running from 3 to -3, and nothing changes along my x-axis. So I've just got a much steeper, I've sort of taken this graph and I've just stretched it vertically. Second of all, I need to complete a horizontal compression now. So I need to have this thing cycling through twice as fast. So what does that mean? Well, if I was to have 360 degrees here, I now need to get 2 cycles done in that time. Okay, so I need to complete 1 cycle in 180 degrees. So I need to start up here and I need to finish up here. So I kind of come through and do something that looks a little bit more like that. Look, it's not perfect, but you get the idea of the general shape. And that would be 2 cycles completed in my 360 degrees. Again, I'm running from 3 to -3. So this would be 3 times the cosine of x. This would be 3 times the cosine of 2x. Now I just need to add my 2. So I need to do my vertical translation now. So I've still got my x-axis. Everything runs the exact same, 180 degrees, and I'm kind of starting up here and I'm trying to get this one completed in 1 cycle and then another cycle done by that time. Okay, but I'm now no longer running from 3 to -3. I'm coming up 5, and here I'm at a -1 because I've shifted this thing up 2 units. So this would be 3 times the cosine of 2x plus 2 in this particular case. So you can see how we've taken this guy and we've transformed it into this guy over here. And it all comes from just our understanding in the sine transformations video and our other function transformation knowledge, how we can do these vertical dilations, our horizontal compressions and dilations, and our vertical translations. Okay, again, if you had maybe a C value in here, maybe like a -180 degrees or something, you could do a horizontal translation as well, so moving that graph left and right.